Hello.
Hello, everyone. Hello, Anatoly.
Hello.
It's nice to welcome you on our final webinar of the first block of our educational lectures dedicated to clay 3D printing, to some advanced principles of 3D printing and its urban application. We will have two more blocks of lectures. The next one is scheduled on the end of July. It will be dedicated to bioprinting materials. So please subscribe to our Facebook page so you can get some information about it at the time we actually have the dates of the particular webinars. Also, we're planning a summer school, which most likely would be postponed a little bit, maybe to autumn, but it will happen. So also, please register at the first link I've shared in the comments section. Okay, today I would like to introduce Anatoly Berezkin. He is a scientist. He has a PhD in chemistry. He is a researcher and entrepreneur. He is a founder of StoneFlower 3D company, which is making one of the best ceramic 3D printers out there. And today he would be talking about history and some progress of the printers. Welcome, Anatoly. I will switch off. Please begin.
Okay. Anton, thank you very much. I hope you hear me.
Yes, but at this very moment, your camera has stopped for some reason.
Okay, so actually my camera is not as important as presentation, so no worries. Welcome all to our webinar. First of all, I would like to say big thanks to Shukhov Lab and Anton for inviting me to join this summer or autumn school, and I hope that my talk will be interesting. Of course, in this talk, I'm gonna present my point of view on the progress. I'm not sure that I will mention all the people who are really important. So before the start, I wish to say my excuses to those people who maybe will not be mentioned, but I guess we all are more or less contributing in this progress. And it's still many opportunities to develop this field in the future. So first of all, I would like to mention that actually in my opinion, clay 3D printing is very closely related to the construction 3D printing with concrete. And we use nearly the same equipment, very similar nozzles, pumping devices, generally routing equipment. So maybe it makes sense to combine them in some sense together and consider related equipment together. So here I will miss my introduction and just we'll start with some overview of automated rotors which could be used for deposition of clay or concrete. First such device was invented and proposed in the 1938 by William Pollard in the United States, and he proposed position controlling apparatus with 5 degrees of freedom. It's kind of predecessor of CNC rotor or robotic arm. Unfortunately, it was never built, but it was patented, and many engineers were inspired by this idea. In the end of 40s and beginning of 50s, United States were investing a lot of efforts into development of new aircrafts, helicopters, and many companies were contributing, working on the orders to accomplish orders from government. And one of those companies has invented and built first numerically controlled machines. Then development of those machines gradually migrated to MIT, and industrial production of such devices has been started. So there were even no computers on the market at the time, but those machines were programmed with tapes and holes on those tapes, paper tapes. So in 1962, first robotic arm was built by George Devil for General Motors, also in the United States. So it's a little bit all about United States. I'm sorry. And in the 18th and 90s, already automated robotic was available for industrial use. And for example, such Japanese companies like Shumitsu and Hitachi, they have built their big offices, skyscrapers in Tokyo using automated robotic arms for slip casting, automated assembly, automated welding, and all such processes. It was not concrete 3D printing, not contour crafting yet, but all those technologies were already available at the time. And in 1995, Dr. Berezkin from University of the image in the right.
I'm sorry to interrupt you, Anatoly. Maybe we can try switching off your video so we can only have your sound, because the connection is skipping a little bit.
Okay. Now it's better. Hello, do you hear me? Okay, great.
Yes, we do hear you well.
Good. So he patented contour crafting, and which is similar to modern concrete 3D printing, as we call it. And in the year 2006, he started commercialization of this technology with help of Singularity University in the United States. It's actually a non-governmental foundation. And to this guy belonged this phrase about that by the end of 2010, I can build a house in one day with our technology. But all those devices which I was talking about were mainly for industrial use. Very big companies were producing them and using them, and prices for all equipment was very, very high. And on the other hand, many people were already informed about such possibility of additive manufacturing, and they were interested to try this technology at home or in their small business. And this probably led to appearance of the RepRap project, which was founded by Adrian Boyer in the University of Bath in England. His initial idea was pretty academic, that we can build such magnificent device which can reproduce itself, and you can print the printer for your own, then you can print the printer for your friend, and in that way those printers can populate the world. And of course, many components of modern 3D printers are non-printable, but generally this project became a huge source of different affordable technologies of additive manufacturing, and it has a huge impact on the full industry. First of all, it was the very first low-cost 3D printer for desktop use. Then it was the main source of inspiration of this open source trend in 3D printing area. And nowadays, this printer or its derivative technologies or derivative commercial printers are most widely used types of the 3D printers on the market, at least according to this survey of 2017. You can see that RepRap project occupy a huge space of market, or so to say. It's very popular among users of 3D printers. And among many other technologies developed in frame of this RepRap project, one technology was extrusion of pastes and viscous liquids using small medical syringes. And this technology was the first technology applied for ceramic 3D printing in desktop scale by this person. This is Dries Verbruggen from Netherlands. He has the studio Unfold in Antwerp, and he was an artist and designer graduated from Design Academy of Eindhoven. He made huge contribution to the nowadays development of clay printing equipment. I just want to show you the list of his achievements which he made in 2009. It was the very first open source ceramic 3D printer. He used volumetric extruder with syringe. He also tried to use air-driven extruder. He tried to combine motorized printhead and external source of clay to improve quality of deposition and better control over the clay flow. And he even tried 3 different types of Moonni extruders. I should say that Moonni extruder, even nowadays, it's kind of a unicorn technology. Everybody knows about this. Any maker dreams to build Moonni extruder because it's gonna be very efficient, precise, and simple in use, but nearly no one is really using this, and it's very difficult to build, in fact. And this person just made use of it before any forums and any available on internet information about building 3D printers for clay. He is driven by ideas of open source, making your own things instead of buying them from IKEA. And he was going to transform pottery in digital era. Actually, he did. Another important person in evolution of clay 3D printing is Jonathan Kep, also artist from London College of Art. In the year 2000, he was introduced to computer 3D modeling instruments and started to learn how to use the software to create new shapes and structures. And he was very impressed by opportunities to do so on the computer. How easy is this, and how many forms you can produce and program. And somewhere in the year 2010, he started to search for the opportunities to print his ideas and make them real. And he immediately found on internet Dries Verbruggen, and they started collaboration. Actually, you can find very good interview on YouTube with Jonathan Kep following this link. And here, is the third person who inspired many people to start printing clay while they have never been doing this before. This is Oliver van Herpt. He is also artist and designer from Design Academy of Eindhoven, actually from the same place as Dries Verbruggen. And he already built his first printer in the year 2012. This was Big Delta. Nowadays, up to now, it's one of the best clay printers in the world, I should say. and it overcomes many commercial models of 3D printers. He built not only printer, but he created a huge number of very diverse and very interesting, inspiring concepts, clay prints, shapes, and textures. And many people, including me, was just amazed by these sculptures and got this feeling that, wow, really clay could be much more interesting than printing plastics, for example. And I guess such impression this person made on many people, and very soon in the same year, first commercialization of clay printing technology has happened in Italy. Massimo Moratti launched his world's advanced saving project. This was the very first successful commercialization of clay printers. Also, he created and designed very nicely looking open source 3D printable clay extruder, and this extruder was used in many research projects separately from printer. People just were able to print this extruder from plastic and extrude clay. And he also built hybrid of FDM 3D printer and clay printer, which was pretty clever at that time. And after the first commercial success of such printer and such company, many other companies started to appear around the globe. This was the Lutum in Netherlands, Potterbot in the United States, and Gaia Tools in Poland. Unfortunately, Gaia Tools nowadays doesn't appear on the radar, so it seems like they stopped doing anything. But other companies exist and produce the printers. And all those printers were for commercial use. It was relatively big printers, pretty advanced, and prices were relatively high. So those printers were available for universities, art colleges, or small businesses, but not for individuals. And in the year 2014, Jonathan Kep decided to create a group called Make Your Own Ceramic 3D Printer. This group was very conveniently placed in the Google Plus groups with very good forum, very good platform for communication, exchange of ideas. And Jonathan Kep have posted there his first printer for clay. This is the small delta which is shown here on the image. And actually Jonathan Kep, Dries Verbruggen, and Tom Lohrmann, artists from United States, they were administrators of this forum. For many people, this forum was the source of engineering ideas, inspiration, and great place to communicate. To me, it was the sign of big transformations that may happen or happen in the business industry. What I'm talking about. Normally, up to now, all the businesses were like black boxes, which keep inside corporative secrets and filter out only very polished information about their business processes, products, and relationships with customers. And all producers, all commercial producers of 3D printers were there on this forum, and people were able actually communicate with them directly or indirectly and discuss their technologies. And this all made those businesses kind of semi-transparent. and this made climate business situation and relationships with customers more fair, more clear and transparent, and this was definitely the change to the best. Unfortunately, in the year 2018, Google decided to make a cooperative instrument from these Google Plus groups and sunsetted them for individual users. So welcome back to the dark side, I would say. But this group didn't disappear. Thanks to our great administrators, they took care about all this huge amount of information which was collected, and all this information was migrated to the Wiki Factory. It's a modern alternative to Google Plus groups. You can find this group nowadays here, and you can find me there as well, unavoidably. And at the golden age of this Google Plus group, there were over 3,000 members. And according to surveys made by Tom Luhrmann, there were like 30% of people from Europe, 30% from North America, 50% of members were artists and designers, 40% are engineers, and about 10 are others. So to me, it was quite surprising how many people with engineering background are there. And we were very efficiently discussing their different engineering solutions. And since the group was rapidly growing and engineering solutions became more and more affordable and efficient, at a certain point, it became clear that on the market of customer 3D printers, there is a huge gap, and we have big printers for industry, but we don't have small printers for individuals. And many people decided to start the business, and we got the second wave of commercialization. Sorry. Yes, it's here. It's an era of Kickstarters, I would say. This started in the year 2017 with the first clay printing startup, Clay XYZ. This startup somehow failed because they didn't deliver anything to bakers, but they kind of were a good example of how you can launch the business on Kickstarter, how you can advertise it, how you can present it to customers, how to communicate with them. And this was actually very, very useful, I guess, for all people who try to do the project on Kickstarter later. Unfortunately, nowadays, Kickstarter is kind of an art of impossible because prices are getting low. The reason of this is that Kickstarter made life of founders quite secure. They may not return money to bakers and nothing very dangerous will happen with them. And on the other hand, customers tend to reduce their risks, putting money into less expensive devices. This all caused significant drop of the prices of goods delivered through Kickstarter. And unfortunately, it makes investments there more and more risky. Nowadays, people mainly use Kickstarter for marketing, but you can hardly earn some money there. That's my opinion. And it looks like Chinese, as you can see from this Kickstarters, StoneFlower was in 2018 from Germany. Then we had Jonathan Kip, Michael Cheng ceramic 3D printer, then SRAMBot from China, and this was from China, and Bottery from United States, and Digital Ceram again from Hong Kong. So it's Chinese marketing platform accidentally located in the United States. Now I wish to disclose a little bit my black box and show you how I did develop my printers, how did it started. So in the year 2017, I had a self-built CNC router based on electronics from RepRap project, actually. And with this prototype, I was able to make my first print, which you see here. Then, quite rapidly, I built a 3D printer of industrial scale, which was pretty advanced at that moment because it has all metal aluminum frame, 32-bit electronics, and it was powered with compressed air. I was able to print such vases. But then I had a couple of accidents, and some of them were quite dangerous. I had exploded a couple of barrels with clay, and I decided that since my printer is not going to be for military applications, I don't brave enough to kill my customers, and maybe it's better to switch to mechanical RAM. At that moment, it was very my luck that Jonathan kept posted his portable mechanical RAM extruder, and I made not a clone or copy, but I just was inspired by this idea and made my own mechanical RAM. Yes, and you can see the spot of clay on the ceiling from those accidents. It was really quite dangerous when 1 kilogram lead fly around your head. At the sound speed, it's not that great. And yes, by the end of the year 2017, I already was able to make such nice prints shown here and had a commercial version of the RAM extruder and commercial version of the Printhead. The year 2018, I started with Kickstarter in February. In August, I have developed already a RAM extruder for 1.5 liter of clay, and my kit was able to print not just ceramics but also deposit different paints and pastes on the flat surface. And this blue image here you can see is actually also painted with ceramic 3D printed kit. And I, in September, designed a new control unit, which made possible to connect the kit to nearly any desktop 3D printer. At that moment, the available quality of the printing was 0.25 millimeters, so 1/4 of the millimeter. It's comparable to the quality of FDM printing with polymers. Not so bad. In the year 2019, the main product became a clay 3D printer, which was already quite notably improved, polished, and production of this printer was nearly optimized. Here you see one example. It's Research 3D printer of desktop scale, which is able to print technical ceramics in Erlangen University. And it can even print 2 different types of ceramics together, as you can see on the left image. And main product is this printer of larger scale. It's 50 per 50 per 50 centimeters printing volume. And you may see how the Printhead, for example, had evolved during 6 months of the year 2019 from this very basic construction with 3D printed from metal auger screw up to pretty elaborated construction with screw from stainless steel and auger extruder CNC milled from aluminum. And this printer gives you already this quality of printing, which I'm quite happy about. Okay, this was a short advertisement, and then I wish to go to the end of my talk and discuss a little bit perspectives of clay 3D printing. I'm not really sure that the main application is going to be something like printing houses on the Earth from Earth, on the Moon from Moon, and on the Mars from Mars. I guess that there are many possible applications for us for clay 3D printing. And first of them, and I don't know is it most important or not, it's materials. We have many materials which are pastes, suspensions, or highly viscous liquids, which can be printed. But we have not many among them which are specially designed for the use in 3D printers. And this is kind of the gap which can be rapidly filled in the future. Second option among use of new materials is two-component polymers, polyurethanes, epoxy resins. They can be used in 3D printing with extrusion much more than they use nowadays. Also, we can combine certain target and living components. For example, here on the image you see this combination of aluminum oxide, which forms ceramic upon burning, and living component calcium carbonate, which serves as a support structure. And calcium carbonate will be removed upon burning and can be dissolved in the water. So you can print quite sophisticated structures which will withstand against the gravity force using just two components. Next direction of interesting applications are new technologies. They are not so easy to predict because all of them created require some engineering creativity. So we may see only part of possible opportunities, future opportunities. On the left side, you see one of the very first and very interesting examples made together by Jonathan Kemp, Charles Stern, and Unfold. They combined glass and ceramics together in a single object. And in frame of this project, they made many such prints or glass bottles. This is one example. Another example could be rapid liquid printing of concrete, which I made. You can watch the video on YouTube following this link, or read the defensive publication in Hackaday, which we made. Idea is the following. You can use the clay mold as a viscous scaffold, and inside this container with clay, you can extrude the concrete or mortar. Initially it is liquid and is just hanging in the surrounding of clay, and it gradually cures with time. So after 3 days you just get a solid structure from concrete embedded in clay, which you can remove. And this method led you to print very rapidly very complicated shapes, and can be true breakthrough in clay 3D printing, concrete 3D printing, in architecture maybe, I don't know. This is just one of the first experiments. And other directions could be new applications and customized products. Customized products maybe are mainly interesting for the business, for clay printing businesses, which could let the customers to choose the color for their prints, shape, texture, and just print what the customer really wants instead of mass production of some repeatable structures. Here I'm gonna present another example. This is the project which was done with my printer by Gabriel Steinmann from Art Academy, Kunstakademie in Munich. This is a set of special containers intended for clever consumption of the food. You can store in those containers some food, and idea is that you don't need to use the fridge to store them. You can just use container with two walls. In between walls you can add the water, and this water, being gradually evaporating through the external wall, cools down the container. You can use containers of different size to buy and store as much food as you need. So you don't need to waste excess of food which you didn't eat at a certain point. And you can comfortably stack those containers together and save the place for storage. You can also rotate those containers, showing how much food left in each container. So it's a device which combines many functions and also have very nice external design which can be customized. That's one of possible examples. So that's all for today. Thank you very much. Thank you for listening. And I hope I can now switch to the questions.
Anatoly, maybe we can try putting your camera back so we can see a little bit more of you.
A little bit more of me. Okay, where I am. I cannot find me.
I'll try switching you on. No, there's, I don't know. Dear visitors and listeners, do you have any questions to Anatoly? Oh yeah, here he is. Actually, if you're planning to build something, I think it's the best opportunity to ask something technical from Anatoly because he's very experienced in building machines. Also, check out the last video, the YouTube link on the rapid liquid printing of concrete inside of another liquid. Do you see the questions, Anatoly? It's in the chat section.
Okay, I see questions, so maybe I have to start from start.
We didn't have much questions, actually. There is one question from Daniel Bade. What's the biggest size a ceramic printer could be built?
Now I know that if you are talking about, well, it's not limited by possibility to build the printer itself. It's limited by possibility to print something big. It depends. If you print from pure clay, as far as I know, the tallest prints are about 1 meter or 80 centimeters. For this, you will need really just likely diluted clay or natural clay of drawing viscosity and print with quite big nozzle, about 8 millimeters.
I would add that it's mostly limited by the size of the kiln you're using. Like in most of the times you are planning to fire the piece after you actually print it, unless you're printing with Adobe, which is kind of rare situation. So it's almost it's possible to build any size of the machines because concrete printers can go up to a building size of the machines. So you could stuff some clay inside. Well, I hope we answered this question.
Yes, then I see the questions about consistency of the clay.
Yeah. I can insert some coins about that, or maybe you can start first.
Yes. In my first experiments, my idea was that you need to have quite diluted clay which can still keep shape against the gravity force. So when you mix it and try to form by hand some structure, it should not collapse. But technology improves, of course, and you can print more and more hard clay nowadays. For example, in my presentation, I showed Gabriel, who print with clay. He was using nearly non-diluted clay with 25% of water there by weight. So if you are searching for the good concentration, I would recommend to take the clay from the back, which has about between 20 and 25% of water, and you can add there another 15% of water and start with this. And if you will be able to try it gradually, you could increase the viscosity more and more, add less and less water.
Yeah, I would say 24% of moisture by weight is a good starting point. It's an average. In my clays that are available in Russia, both white clays, stoneware clays, and red earthenware clays. Also, the interesting thing, if you start adding some non-clay particles like shamot fillers, it actually makes the mass more viscous, which means it's easier to move it in the hose. Because I was really surprised by this knowledge when I first thought of it. But basically, adding very fine sand into the clay makes it easier to move into in the tube. And also, you can make it less moist if you add some more non-clay particles to it. Actually, I've shared this link to the Jonathan Keep's handbook on ceramic 3D printing, and I'll share it once again in the moment. It has most of the answers actually on this topic.
Yes, exactly. Videos of Jonathan Kep are very good and helpful material. You can watch them, and he explained in very details how the clay should look like and how it should behave to be printable. And he literally show it, and you can get some feeling about this. So there is criterion also for extrusion of for extrusion tests, so to say, if I can find. So you can just take the syringe like this one for 60 milliliters, put it on balance and press with the force which is equal about which is between 6 kilograms and 7 kilograms. And if here you have a hole 8 millimeters in diameter and can extrude your clay, it's probably a good clay for printing. Actually, this force about 6 kilograms is equivalent to the pressure of 1 atmosphere. If you can connect your compressor to the syringe, you can set 1 atmosphere pressure over pressure, I mean, so. And it will be nearly the same. Concerning exactly my printer, I have a video manual on YouTube. You can also find this video on my website in the support section. And there I show how to prepare clay and how it may look like. Actually, nowadays it may be even much less viscous than shown there.
I think we have some more questions. We actually have a bunch of them. So I have a problem getting right liquid. We just answered that. Follow the link. It has some list of commercially available clays. Also, search for a ceramic 3D printing group on Facebook. I personally answer some questions over there. If we don't answer them right now, we just make a post on this group and I will answer them, or maybe Anatoly will. So the next question, which kind of extruder is more preferable? The ones with compressor or without? I personally, I like more working with a RAM. because it's silent and it's more precise. But if you're just only starting, it's way easier to start with a compressor feeding, because if you have a compressor, you just need a hose and you plug it in and you go.
One comment. So it's very important to take care. So as always, safety first. The problem with air is that when you break some container, the parts of this container they just explode, and compressed air push them. So it's not the same with mechanical RAM, for example. When you have non-compressible liquid, and if you get some crack on the RAM, you will just have a very small leak of the clay and nothing more. If your pressurized container had a crack, it will explode. And you should understand that if you take some plastic components and add some connectors on your own, probably in the holes you drill, you create additional stress, and this may facilitate explosion. So you should be really very, very careful designing your own containers for clay. You may see actually that main producers of clay printers who use compressed air now, since last 1.5 years, they use only metallic containers. I guess it's really to make all those equipment much more safe and prevent explosions.
I would say that's mostly because metal tubes are just more precise than the plastic ones. And for example, the Dutch printer, they're actually using a plastic container inside of a metal container for easier filling the tubes. But yeah, the tubes do explode. And if you are planning to build something from scratch, like I would. Like usually you have to use something between 4 and 6 bars to press the clay, and if you're planning to make a cartridge yourself, take a tube which is at least 10-12 bars, so it has some additional strengths. Yeah. So.
Okay. Next question. Do you see better which questions we have? I see people ask about concrete.
Yeah.
Do you have any experience in cementous materials and printing concrete? Yes, I do. As I've shown, I use it for rapid liquid printing. Some people are using our printers for printing concrete in research purposes. For example, Technical University in Dresden. You can use RAM extruder, but you have to prepare your concrete in quite a specific way. The problem with concrete that it contains the particles of very different size, and they all tend to sediment, but they, move down under the gravity force. But sedimentation of different particles is different, and as the result, after a certain time, without mixing in your container, you will have a gradient of the density. Most of the particles will be somewhere at the bottom, and more water will be at the top. To prevent this, in normal concrete, you have to add kind of stabilizers of viscosity. I use bentonite, and bentonite is also recommended for use in 3D printable clay compositions. Jonathan Kep, for example, recommends this in his last research on 3D printed clays. He recommends to add about 5% by weight of bentonite. I totally agree with him, so I use nearly the same concentration. And this makes concrete much more printable. You can use barrel, which doesn't mix the clay. if you want to make it on the larger scale, I would say now there are available, for example, pressurized containers for 5 liters of material with an embedded mixer, which is pneumatically driven. You can find them on Alibaba, for example, and buy there from China. That's an option for concrete. I guess it's a good option. I have never tried. It's quite an expensive experiment. It's 500 euro per device. But it looks like a good opportunity to print concrete.
Okay, thank you. The next question we have about fillers. What do you think about using some smaller particles, fibers, and additives to achieve a better structural performance? Before Anatoly would answer this, we will actually have a separate webinar dedicated to some biological fillers by one scientist from Canada. His name is Aaron. It will be in the second half of July. It would be one of the first webinars in the second block, so please subscribe not to miss that. Do you have, like, my personal experience about adding fibers is that most of them burn out, and usually that's what you want to do, like adding paper mache inside of clay works nice and makes a better clay in terms of isolation, for example, because it's more porous. So do you think anything about structural performance, Anatoly?
Well, there are different aspects and different effects which additives can make. So one example again is last post of Jonathan Kepp. It's a very good example. He tried to print paper porcelain. How does it called in Germany? It's a mixture of clay with some cellulose or paper, papier-mâché. Even small amount of this additive makes the surface of print very rough, and it's actually very, very sticky. And this general tendency when you add some very anisommetric particles, your materials start to behave like a molten polymer and or resin. It tend to flow with certain delay after application of the load, and still tend to flow when you don't apply the force anymore. So it's called scientifically viscoelastic behavior. And sometimes it's very inconvenient for printing and maybe not so good for the texture in case of paper clay. But in case of concrete, for example, it could be helpful when you add bentonite. Bentonite, it's kind of inorganic polymer with very long crystals, and they just make your mixture more liquid, more viscous, and doesn't let to sediment those particles so much. If you want to print something big, it's better to use clay with chamot. It is lead imposed to contraction upon drying. It holds the shape better, and it survives the burning better than normal clay.
Yeah, but most likely you have to prepare it yourself, and you need a bug mill or something, or you have to mix it dry, and that's a whole problem. One of our visitors is asking about some glass-based experiments. I'm really curious because I have some glass blowing hobby, and I'm actually thinking of trying maybe printing glass someday. You had some experiments with Dina Santos, who was using your extruder?
Yes, I know Dina Santos, and I saw her great prints. Again, it's the same situation when artists create for us new technologies and do engineering work better than engineers. Actually, it's amazing. I'd like to try this with her. Maybe one day we will do it.
So do you have any actual examples to share? Maybe a link? I haven't seen it actually.
Mm-hmm. You can find on the Instagram 3D Do It Art. 3D Do It Art. I guess so.
Okay, I'll check it out.
Yes.
I think our time is almost up. I think it was a very productive question and like questions and answers section. Everybody is really welcome to our next lectures. Anatoly, thank you very much. It was very, very technically interesting, and the history.
I hope it's compliments. Thank you.
Everyone, if you have any more questions, please come to our Facebook group on ceramic 3D printing or Wikifactory. We'll try to answer most of your questions. We're not trying to hide the secrets. So
thank you very much for this opportunity. It's really great to me. I'm very happy that I joined your school. Thanks.
Thank you, Anatoly. It was really nice to hear you. Okay, goodbye. See you later.
See you. Bye.
Bye-bye.